students, we have studied about the image formation by plane mirrors. We also know the nature, position and relative size of the image formed by plane mirror. How about the images formed by spherical mirrors? How can we locate the image formed by a concave mirror for different positions of the object? We know, students, concave mirror is a type of spherical mirror, and image formed by these mirrors depend upon the position of the object. So the questions we can ask are these images formed by concave mirror real or virtual? Are they enlarged, diminished, or have the same size as the object? Let us answer all these questions in this video, one by one. For that, let's set up an experiment. So what do we need? A concave mirror, a screen, and an object. So take a concave mirror. Find out its approximate focal length. You know how. We have already taught you. Note down the value of focal length. Mark a dot on a table with a chalk. Place the concave mirror on a stand and keep over the dot such that its pole lies over the dot. Draw with a chalk 2 more dots in front of the previous dots. Remember that the distance between any 2 successive dots is equal here. Also, always take this in mind that this distance equals to the focal length that we have already calculated. So what you do is calculated focal length is to be measured on this table and then make the dots. So now, can you guess what these points correspond to? Correct. The first point is the pole of the mirror, as we have kept the mirror on it. Second point is the focus point or principal focus of this mirror, as the distance that we have measured is equal to the focal length of this mirror. And the third point is the center of curvature, as the distance between this point and the third point is again equal to focal length. That is, the distance is twice the focal length, that is 2f. So let us denote these points as P, F and C respectively. Now move the objects at different positions on this table. Say keep the object at infinity. Then move the object little closer to the mirror. What do you see? The image formed when object was at infinity is different than image formed as we moved it little closer. Now keep the object on center of curvature, that is at C, or keep the object on its focus point F and observe the images. Are they same? No. Exactly right. So as we move object near or away from the mirror, the image formed by the mirror changes. So let us note down our observations. Let's say in case 1, we take object at infinite distance. That is, the object is very far from the mirror. We know if object is at infinity, its image is formed at principal focus. Why? Because the rays coming from object at infinity are all parallel. And we know all parallel rays meet at single point, that is focus point after reflection. So image will be formed here. How is the image? Point size. Yes. Let us represent this with the help of ray diagram. Consider an object AB. Place at very far distance from the concave mirror MN. Now the incident ray AD, starting from A, parallel to principal axis after reflection, passes through principal focus as per our rule of representing ray diagrams. The path it follows is df. This is according to our laws of reflection. Angle of incidence should be same as angle of reflection. The other incident ray BQ, starting from point B, again parallel to principal axis, after reflection will pass through focus and returns along the path QF. You can see, students, it cuts the reflected ray DF at the point F. Thus, image of object AB will be formed at point F or on principal focus. As all the rays converge at actually a point, the image is of point size. The image is real as rays are actually meeting at F, and we know real image is always inverted in nature. Now students, let us write our observation for case 2. That is, when we keep an object at position far beyond the sea. Remember, it is not at infinite distance, it is just a little away from the sea. That is center of curvature. Just move the screen to get the sharp image on it so that we can study these properties of image so formed. Now observe the image carefully. What do you see? Yes, the image is inverted, real and smaller than object. Let us represent this through a ray diagram. An object AB is placed beyond the center of curvature of the concave mirror MN. Draw the incident ray AQ starting from A, parallel to principal axis. After reflection, it will pass through principal focus F along the QD. Draw another incident ray AN passing through center of curvature C. It will get reflected back along the same path as NC. Students, we can see it cuts the reflected ray QD at point A dash. Thus, the image of A is formed at A dash. The point B is situated on principal axis, and so its image will also be on the axis and will be directly above A dash. Thus, the image of B is at B dash. The images of points between A and B will be formed between points A dash and B dash. Thus, the image of object AB is A dash B dash. From this, we see that when object is placed beyond the center of curvature, the image formed is between the focus and center of curvature of the mirror. This image is smaller than object and is inverted because it is real, as the reflected rays actually cross each other. This real image can also be obtained on screen, and that's what we are doing.